when a reaction is never spontaneous, the sign of delta S universe for those kinds of reactions are always negative. So why can delta S universe be positive or negative for reactions 2 and 3? Well, let's look at whether or not they're spontaneous. The answer is depends. This is why the sign of delta S universe can be positive or negative, because these types of reactions, endothermic with an entropy increase or exothermic with an entropy decrease, can be spontaneous or non-spontaneous as depending on the situation. So this is why their delta S universe values can take on either positive or negative values. What is the correlation between the sign of delta H reaction here and the sign of delta S surroundings? Let's look at reaction number 1. We have a positive and a negative, respectively. Reaction number 2, a positive and a negative, respectively. Reaction number 3, a negative and a positive, respectively. And reaction 4, a positive and negative respectively. The pattern is that delta H reaction and delta S surroundings, the values always have opposite signs for each reaction, for each type of reaction. The sign of delta H reaction determines the sign of delta S surroundings, as we just found in the last question. Explain why this is true. Well, let's just think about this logically. In exothermic reactions, where delta H reaction is positive, heat is given off by the system. In endothermic reactions, where the sign of delta H reaction is negative, heat is absorbed by the system. Since heat excites molecules and sends them into a state of greater disorder, think back to ice melting, think back to liquid going into gas, evaporating. Since heat excites molecules and sends them into a state of greater disorder, or in a state of less order, it makes sense that the delta S value for the surroundings will increase. Therefore, it makes sense that if the surroundings receive heat from the reaction going on, their entropy will increase, and if the surroundings have to give up heat to the reaction that's going on, their entropy will decrease because the order is going down, because the energy contained in the surroundings is decreasing. Number 9. On the table above, the sign of one value determines whether or not the reactions are spontaneous. Which value sign determines the spontaneity of a reaction? Let's examine reactions 2 and 3. Their spontaneity says not yes or no, but depends. And knowing that, which of these 4 values can take on either positive or a negative value? That's going to be delta S universe here. Clearly, this is the determining factor in spontaneity, because when it's definitely positive, the spontaneity is definitely yes. When it's definitely negative, the spontaneity is definitely no. And when it can be either, spontaneity can also be either. So that's clearly the determining factor. For any spontaneous reaction, the amount of blank in the universe must blank. Knowing what we just went through in question 9, the second law of thermodynamics, we can say we just figured out that the sign of delta S universe determines whether or not the reaction is spontaneous. So we can say that a positive delta S universe corresponds to a spontaneous reaction, and a negative delta S universe corresponds to a non-spontaneous reaction. So to fill in the blanks, we would say the amount of entropy in the universe must increase. Huzzah! In the above information section, the statement was made that when deciding whether a reaction is spontaneous, you need to consider both entropy and enthalpy. If only delta S universe is needed to determine spontaneity, then why do you still need to consider enthalpy? This is a really good question. Delta S universe is the only value needed to determine spontaneity. However, delta S universe is calculated by this formula here, which is delta S surroundings plus delta S reaction. And when you break it down even further, delta S surroundings is computed by